Alright, so this is my ECE 3300 extra credit project for circuits 1. Built a like blinking LED circuit or a relaxation oscillator, which uses this op amp LM741 as a comparator, and it's built by this circuit diagram. I used two 9-volt sources from my two power supplies, and I set the reference point to be at 9 volts as ground. So this will serve as my negative 9 volts, and this will serve as my as my positive 9 volts. We have a 10 microfarad capacitor, and that was my given because I only had a limited number of capacitors. So what I did is I took the formula for the relaxation oscillator, which I just got that off of Google, and I solved it for resistance. Then I took my knowns, which was that the capacitor was 10 microfarads. The frequency is 1 hertz because the objective of this experiment is to make this LED blink once every second or 60 times in a minute. So I got the frequency of 1 hertz. Then you solve it, you get your answer in ohms, so it came out to about 45.5 k ohm. And this was just my reasoning for that, which I just said. And the way I got 45.5 k ohm was to put 200k resistors and two 1 mega ohm resistors all in parallel, which gets you pretty close to 45.5. Then the structure of the circuit, this is going to be my feedback resistor, which is right here. That's what actually sets the frequency. And then right here we have the output leg of the op amp with a voltage divider, and this is what gives us the comparator logic, just splitting the voltage between these two 10k resistors. And then we have the LED itself, and I put a resistor right here so that it doesn't fry when it's working, which I don't think there's enough voltage here to actually do that, but I didn't want to risk it. So then I actually have it hooked up to my oscilloscope, and I have one probe connected to the capacitor for channel 2 and one probe connected to the LED for channel 1. And you can see channel 1 is the square wave. I don't really know why the top of the wave looks weird like that. It comes and goes randomly, but you can still see the actual proper waveform. And then I went ahead and used the measure function to find the frequency, and it's very, very close to 1 hertz. So you can see the square wave and the charging cycle of the capacitor, and you can see that they're very closely correlated, which shows that the comparator logic is working pretty well. And yeah, that's about it. Thank you.